Hi everyone, welcome to Winpoint online classes. Now we are going to discuss some of the numerical related to trigonometric ratios. First question, if angle B and angle Q are acute angles such that sin B equal to sin Q, then prove that angle B equal to angle Q. There are two triangles. So first we are going to draw that two triangles. Triangle number 1 and triangle number 2. Okay, there are two triangles. We need to give names for these triangles. This triangle is A, B, C, and this triangle is P, Q, R. This is angle B and this is angle Q. We need to prove angle B equal to angle Q, right? For that we are going to prove these two triangles are similar. First, the given value, the given relation. The given relation is sin B equal to sin Q. It is given in the question. Sin B equal to sin Q. It is given in the question. What is the equation for sin B? Sin B is opposite side by hypotenuse. Opposite side is AC. So we can write AC by hypotenuse is AB. AB equal to sin Q. This is sin Q, this is angle Q. Sin Q will be opposite side PR by hypotenuse. PQ is the hypotenuse. So it will be PR by PQ. Now we have this relation. We are going to make some changes in this relation. Just we are going to interchanging this one. These two terms we are interchanging it. Then it will be AC by, here we are going to write PR equal to AB by PQ. We interchanged it. Now we can say that AC by PR equal to AB by PQ. The ratio of two sides of these triangles are equal. We are going to consider the third side. AC by PR equal to AB by PQ. We are considering it is a constant. Okay. Now we are going to consider the third side, BC. If we are applying Pythagoras principle, what will be the equation for BC? BC square. BC square will be equal to AB square minus AC square, right? AC square. What will be BC from here? BC will be equal to root of AB square minus AC square, right? Instead of AB, this AB, we are considering this AB. From this equation, can you make an equation for AB from this relation, only this relation? Yes, we can make AB will be equal to PQ into K. So we can write BC equal to root of, instead of AB, here it is AB square, instead of AB square we can use PQ square into K square minus, instead of this AC, can we use PR into K? Yes, we can use, because AC by PR is equal to K. So AC will be equal to PR into K. So we can write, instead of AC we can write PR square into K square. Here the K square is common. We are taking that K square outside of the root. It will be K. BC equal to K into inside the root. It will be, first we are taking K square as a common factor and we are taking it outside the root. It will be K. Root of K square is K. And it will be root of PQ square minus PR square, right? We are making a circle here. We are marking it because it is very important relation. Now what is this QR? According to Pythagoras principle, QR square will be equal to PQ square minus PR square, right? What about QR? QR will be equal to root of PQ square minus PR square. We are marking that also. There are two equations now. We are going to divide these two equations. First we are dividing LHS, left hand side, BC by QR equal to RHS, K into root of PQ square minus PR square all divided by root of PQ square minus PR square, right? This PQ square minus PR square and PQ square minus PR square with root, it will cancel and it will be K. So we can write BC by QR equal to K. Now let's observe the relation. BC by QR is equal to K and AC by PR and AC by PR equal to AB by PQ equal to K. So we can write AC by PR equal to AB by PQ equal to BC by QR. Or the ratio of all sides of these two triangles are equal, then we can say that triangle ABC similar to triangle PQR. Then we can say that angle B equal to angle Q. This is the proof. Next question. Consider triangle ACB right angled at C, in which AB equal to 29 units, BC equal to 21 units and angle ABC equal to theta determines the values of cos square theta plus sin square theta and cos square theta minus sin square theta. First we need to draw a triangle. It is a triangle and we need to give the name. When we are giving this name, you need to ensure that in the question it is given, it is right angled at C. So here it should be C. Then A, B, C, right? And some of the values are given in the question. BC 21, it is given 21 unit, and AB 29 unit, it is also given. AB is equal to 29 unit. These values are given. If we know these two values, we can find this value, right? How we can find this value? Using Pythagoras principle. Let's do that first. It will be, first we need to write the equation. The equation is AC square equal to AB square minus BC square. What is AB? AB is 29. 29 square minus what is BC? It is 21. 29 square minus 21 square. 29 square is 841 and 21 square is 441. So from that we can write AC square equal to 841 minus 441, it will be 400. Then from that AC will be equal to root of 400, AC equal to 20. So here the value is 20. Now what we need to find? The question number 1, cos square theta plus sin square theta. First we can go for the question number 1, cos square theta plus sin square theta. Cos square theta plus sin square theta. Angle ABC equal to theta. Angle ABC, it is theta. It is given in the question. You can see that angle ABC equal to theta. First we are finding cos theta. What is the equation for cos theta? Cos theta is adjacent side by hypotenuse, which is adjacent side here. 21. See, BC is the adjacent side, right? BC is the adjacent side and hypotenuse is 29. Adjacent side by hypotenuse, it will be 21 by, and hypotenuse is 29. 21 by 29. What about sin theta? What is the equation for sin theta? Sin theta is opposite side by hypotenuse. This is theta, opposite side is 20, hypotenuse is 29. So it will be 20 by 29, right? We are going to substitute all the values in that equation. It will be 21 by 29 whole square plus sin square theta 20 by 29 whole square, right? Here 29 is a common factor, so 29 square is a common factor here. First we are giving that square inside the bracket. It will be 21 square divided by 29 square plus 20 square divided by 29 square, right? 29 square is a common factor here. 21 square plus 20 square. What is 21 square? It is 441. So we can write 21 square is 441 441 plus 20 square is 400, 400 all divided by 29 square is 841. 841, it will be 841 divided by 841 equal to 1. So cos square theta plus sin square theta will be equal to 1. It is the first question. What is the second question? We need to find cos square theta plus sin square theta, right? Second one, cos square theta minus sin square theta. We need to find this value. First we are finding cos theta. What is cos theta? 21 by 29. And sin theta is, cos theta is 21 by 29. Sin theta is 20 by 29. We are substituting all the values. 21 by 29 whole square minus, instead of sin square theta we can use 20 by 29. 20 by 29 whole square, right? Now what is 21 square? It is 441. 441 by 29 square is 841. 841 minus 20 square is 400 by 29 square is 841. 841 is a common denominator. 841 and 441 minus 400, it will be 441 minus 400. So we can write 41 divided by 841. That is the answer. Next question. In a right triangle ABC, right angled at B, if tan A equal to 1, then verify that 2 sin A cos A equal to 1. There is a triangle. First we are drawing the triangle. It is our triangle. Okay. And we are giving a name. When we are giving the name, you need to read the question first, because it is given that right angle at B. So B should be here, 90 degree. A, B, C. In this question, tan A is given, it is 1. Tan A is opposite side by adjacent side. This is angle A, which is opposite side of angle A, BC. So we can write BC by adjacent side is AB. AB equal to 1. The ratio between BC and AB, it is 1 here, which means AB and BC both are equal. So we can say that AB equal to BC. If these two sides are equal, then the ratio will be 1. So we are taking it is K. BC equal to K and AB equal to K. It's a constant. Can we find AC from here? Yes, we can use Pythagoras principle. AC square will be equal to AB square plus BC square. Which is hypotenuse. Hypotenuse square is equal to first side square plus second side square. AC square is equal to AB square is K square. K square plus K square. BC also K, right? AC square equal to 2K square. K square plus K square is 2K square. And what about AC? It will be root of 2K square, right? AC equal to root of 2, it will be root 2, root of K square, K. So we can write here it is root 2K. Now we need to find 2 sin A cos A, right? That's the question. We need to prove that it is equal to 1, right? So we are going to find sin A first. What is sin A? What is equation for sin A? Opposite side by hypotenuse. This is angle A, opposite side is K. It will be K by hypotenuse is root 2K. What about cos A? Cos A is adjacent side by hypotenuse. Adjacent side is K and hypotenuse is root 2K. So we can write K by root 2K. We are substituting all these values. In this equation. So what we are going to get? When we are substituting all these values in this equation? It will be 2 into, instead of sin A we can use K by root 2K. K by root 2K, right? Root 2K into cos A. Instead of cos A we can use k by root 2k. It will be k by root 2k, right? K will cancel each other, right? K and k cancelled and k and k cancelled. Root 2 into root 2, root 4. Root 4 is 2. So we can say that it will be equal to 2 by 2, which is equal to 1. That we need to prove here, right? Hence it's proved. If tan A equal to 1, then 2 sin A cos A will be equal to 1. Next question. In triangle OPQ, right angle at P, OP equal to 7 cm and OQ minus PQ equal to 1 cm. Determine the values of sin Q and cos Q. First we are going to draw a triangle. If you are listening to this class, please take a pen and solve it with me. Solve the problem with me, then it will be very easy for you. Okay, so we are drawing a triangle here and we need to give a name for this triangle. It's given in the question. It will be OQP. OPQ, that is the name of the triangle, and this angle P, it is 90 degree. The length of OP, the side OP, the value is given, it is 7 cm. And there is a relation which is given in the question. OQ minus PQ equal to 1. In this triangle, we are going to apply Pythagoras principle. When we are applying Pythagoras principle, we will get OQ square equal to PQ square plus OP square. Can we make an equation for OQ from this equation? Yes, the value of the equation for OQ will be 1 plus PQ. Here it is minus PQ. We are taking that minus PQ to the other side of equal. It will be plus PQ. And we are going to substitute this equation in the previous equation. It will be 1 plus PQ whole square equal to PQ square plus OP square. Instead of OQ, we are using 1 plus PQ whole square. It is in the form of A plus B whole square. A square plus 2AB plus B square. It will be 1 square plus 2PQ plus PQ square equal to PQ square plus OP square. This PQ square and PQ square will cancel each other. It will be 1 plus 2PQ equal to OP square. The last equation is 1 plus 2PQ equal to OP square. What is the value of OP? The value of OP is given in the question. It is 7 cm. Then we can write 1 plus 2PQ equal to 7 square. 7 square is 49. Then it will be 1 plus 2PQ equal to 49, right? From that we can make equation for 2PQ. 2PQ will be 49 minus 1. Here it is plus 1. When we are taking this plus 1 to the other side of equal, it will be minus 1. Then it will be 2PQ equal to 48. Then we can write PQ equal to 48 by 2, which is equal to 24. We got the value of PQ. It is 24. Now we can find the value of OQ using this equation. We are going to use this equation. Equation for OQ. OQ equal to 1 plus PQ. OQ equal to 1 plus, the value of PQ is 24. 1 plus 24, which is equal to 25. So value of OQ is 25. The question is, read the question again. We need to find the value of sin Q and cos Q. We are going to do that. First we are going to find the value of sin Q. What is the equation for sin Q? Opposite side by hypotenuse. It is the angle Q, which is opposite side 7. 7 is the opposite side and hypotenuse is 25. So we can write 7 by 25. And what about cos Q? Equation for cos Q is adjacent side by hypotenuse. It is the angle Q, adjacent side is 24, hypotenuse is 25. Then it will be 24 by 25. So we already, the value of sin Q is 7 by 25 and value of cos Q is 24 by 25. If you like this video, please subscribe to this channel. Visit our website www.winpointonlineclasses.com. Support us for providing free online classes for everyone. We are going to solve all the textbook exercise in this session and we are going to discuss some of the important numerical in the exam point of view. Thanks for watching.